Hello and welcome to this week's guided project. Yes, we are going to be doing another project this week. This project is fairly ambitious. It's going to be the most ambitious project we've done to date. And what we're going to do is we're going to write a tic-tac-toe game, simple tic-tac-toe game. So we're going to implement in this project some of the things that you should have picked up from Chapter 7 reading and PowerPoint notes on arrays. So our game board in this tic-tac-toe game is going to be a two-dimensional array, 3 by 3, and that's going to serve as the data structure that keeps track of who's played where. And then that will also serve as the object that we pass to functions that will analyze the game board and determine if we have winners. So what I want to do first is I'm going to launch a finished version of the game for you and just kind of give you a feel for how the game plays out. Of course, I'm sure most of you know how to play tic-tac-toe, but this is just going to give you a visual cue to start with how and when to display the game board and how I'm doing it. Okay, so you can see here that initially I just have the game board spit out, or I have the game board displayed as 9 numbers in a square pattern. Now if you wanted to, you could get fancier and you could try to put in the hash marks into your game board. And I encourage you to experiment with that and do that. But this project is going to be time consuming as it is, as you can see by the length of this video. So it's going to be time consuming as it is. I encourage you to, like I said, go ahead and experiment with the display of your game board and get it to look how you want it to. Okay, so after it displays the numbered board, it prompts the user to pick their square, and I have it programmed so that the user is always X. So I'm going to pick 5, and after I pick my square, it will put my X in that location. And then I have it also take a turn for the computer, and notice the computer here chose 8. Now currently we will not have any logic for the CPU that gives it some intelligent gameplay. So right now what this program is doing is that the computer is just picking one of the open squares at random. Now what that should allow us to do is it'll give us the ability to test out all of our game winning logic, so we should be able to win a game pretty easily. We should also be able to tie a game pretty easily, and if we can pick the right squares and guide the computer towards a win, then we can probably throw a game as well, so that we make sure our logic's working. And then again, on top of that, if on your own time, if you would like to try to program some intelligence into the computer's choices, then that's entirely up to you. Okay, so then the game continues to play out. I'm going to try to win this game. So I chose 7. Luckily he didn't block me, and so I should win with 3, and I did. Now the game closed on me because I launched the exe outside the context of the dev compiler. So if I just put in a cin statement, then I can view the board. So I just did that, and playing another game here, and I should be able to win fairly easily again here. Okay, so now you can see the game board, and I won with a cross, and it says winner winner chicken dinner. Okay. Okay, so let's get started on this thing. I'm going to create a new project and call it tic-tac-toe with my last name, first initial in front. And I'll create a new folder for it. Okay. and then a description, and I'll say this program plays a game of tic-tac-toe versus the computer. Fairly simple. Okay, so the first question is where do we even start making something this large? I always start with the display, and this goes for not only console applications but GUI applications as well. Design the user interface, and then you can build the logic piece by piece from there. So first of all, we need a way to keep track of the game board and all the elements in the game board. So what I first did was I created an array that serves as the game board. And so the user's typing in X's and O's, or well, the user's choosing a number, and then that number determines which which square or which location on the game board that their X or O gets placed. So X's and O's, those are characters, individual characters. And what I actually did with that game board where it's displaying the 1 through 9, I made those the characters 1 through 9. So what I did is I created a character array, so CHAR, and then I just called it game board. Okay, what you should have picked up from chapter 7 is that there's a lot of different ways that you can initialize or create an array. Our game board is going to have 9 total squares in it. What I'm going to do is create a global constant, and I'm going to just call it squares and set it equal to 9. So I'm going to do const int squares. Okay, and then that is the constant that I'm going to put in here for my array initialization. And then I'm going to go ahead and fill this array with values. And if you remember that from chapter 7, or you picked that up from chapter 7 as well, then you should have noticed that you should have discovered that you pick you start by typing the curly braces, and then in those curly braces, that's where you can initialize an array, comma separated values. So although I said I may have said that this was a two-dimensional array, it doesn't have to be. Really, the display is two-dimensional, but we can accomplish that with just an end line. I'm going to have this just be a regular one-dimensional array, and each element in this array is a character. 1, 2, 3, 4, 5, 6, 7, 8, and then 9. And notice I'm putting the single quotes around the number. So this isn't an integer array, it's a character array. It's the character 1, the character 2, the character 3. And so that's different than being an integer. And why did I choose characters again? Like I said, I want to be able to replace these values with X's and O's. And again, that's my game board. So this is the visual game board. Okay. So now that I've created this array that serves as the game board, I just want to try to display it. So I'm going to create a function that does that, because as this game plays, we're going to continually redisplay the game board. So it makes sense to create a function. So I'm going to create a function called display game board, or display board, and it will be a void return type. It's just going to have the cout statements that displays the board. So I'm going to create a void display board, and I'm going to have it receive that character array. And I'll call that character array game board as well. Okay. So to display the board, the logic that I need here, I already know how many times I need this thing to iterate. It just needs to iterate through the array. And that's something you should have also read and picked up from chapter 7, is that arrays lend themselves nicely to for loops. So I'm going to do for int row starting at 0, and then going till row is less than, and I created that constant so I can just use it. Row is less than the total number of squares, which is 9, that we have as a constant. And then I'm going to increase row. So this should cycle through the entire array, and all I really need it to do is output that element in the game board. So cout game board, and again, this is new, how to pick an item from an array. How to pick out an item from an array. You just pass the number. Now in this case, I'm going to use this integer row here, and that will cycle through the array, and as row is increased, it will display whichever numbered element. And so remember, this is a 0-based index, the array is. So array element 0 is the character 1. Array element 1 is the character 2, on up to less than 9. So array element 8 is the character 9. And I'm going to also display a space. Okay. Now I don't want an end line after every single element that I display in the array. It's only after every 3, right? So I display 1, 2, 3, then I want an end line, 4, 5, 6, then another end line. So the logic that I'm going to use for that, put an end line every 3 squares. I'm just going to have a simple if statement, if. And there's several ways you could do this. The way I did it, I used the row integer, and I did row plus 1. The modulus of that, and so I'm going to encapsulate it in parentheses here. That modulus 3, if that is equal to 0, then I want an endline. Okay, so in other words, I'm adding 1. This being a 0-based index array, which all of them are. Every third element, that's when I want to do the modulus. Now, like I said, there's other ways mathematically you could do this, but this way made it easier for me to think through. If I just start at 1 every third, after every 3, once the row hits 3, and that's why I'm doing this after this. I want to display the third element, or element, well, it'd be element number 2, 0, 1, 2. I want to display that character 3, then I want an inline. And so that's why I'm adding 1 to the row. So element 2 plus 1 is 3, 3 mod 3 is 0. That's where I'm going to add my inline. Okay. And then in this display board, after that whole thing has been displayed, I want to throw in another end line. So we have a little extra space in there before it displays, it goes on and plays the rest of the game. Okay, so I've actually defined this function before I've declared it. I haven't declared it yet, and I want to actually call it here in my main, so I need to declare it. And if you just take this top line, the header line of the function, and copy it, then you can just paste it up here, put a semicolon after it, and then call it good. Of course, I'm going to put a little description here and just say that this function displays the game board, which it is receiving as a character array. Or an array of characters. Okay, let's call that in our main display board, and we're going to pass to it that game board that we're creating here. Now, some of you might think, well, what if could I just put this array as a global variable up here and pass it around? I don't think I would have too much of a problem with that, although it is generally frowned upon to create global characters like that because it can be hard to maintain them. And this, again, this is the largest project we've created so far, but it is still relatively small compared to actual business applications. So in business applications, you wouldn't want to do that. It can be too hard to keep track when you have, you know, hundreds of thousands of lines of code and you know, hundreds of functions. Not a good idea. But you know, for this, if you did, I wouldn't fault you too much. I think eventually, once we get to the class portion of this semester, where we start to learn to create our own classes, that's really what you're doing inside of the context of a class, is you're creating a global variable for the class. So it's global to the class but can't be seen outside. Anyhow, I'm going to kind of stick with the rules here and leave mine as an array inside the main. Okay, when you're writing programs this large, you want to take time out and test every little bit and make sure that what you've got is working, and then you just kind of build upon that. So anytime you're faced with a larger project like that and you don't know where to start simple. Start with just displaying something and then build on that. So I'm going to try to run this as is now, and got a small issue here. Oh, see, okay, so yeah, I forgot my using namespace standard again. You guys need to remind me about that. Okay, so now that I've added that, we shouldn't have those problems. Sometimes it's kind of hard to decipher what it's telling you the issue is. Okay, so there it's displaying my game board, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's it. Okay, so far so good. Alright, the next step, I believe, is to, since the user is X and he's playing, always playing, I want to try to create a function that allows the user to pick one of those 9 squares and it should place an X character in that array, and then we'll display the game board again. Okay, so I'm going to call a function that I'm going to call player turn. Passing to it the game board, and I'll go ahead and define the function and then I will declare it. So player turn, I'm going to come down here underneath my game board function, and this is also going to be a void function, and I'll just call it player turn, and it will receive that character game board or character array. Okay. So essentially what we want this function to do is prompt the user for one of the numbers, say, you know, pick a number, and we read that in, and then we just place it on the board. So I'm going to start simply and assume that all of the squares are open, test that out. Then we need to go back and add logic to make sure that the user isn't picking a spot that has already been picked. Obviously that wouldn't be any good. So we're going to start small and then build on that in this function as well. So starting small, I'm going to create a character that the user will type into, that I'll call, or will receive the user's input. Board location number, I'll call it int. In board spot maybe. And then prompt the user. Okay, and I'll create a cout statement here. Your turn. Pick a number to place your X. Okay, and read that value in. Okay. Okay, so for now, what I'm going to do is just take that game board, and I'm going to place in the number that they chose. I'm going to place an X character. Okay, so the number that they chose is actually going to be one more than the actual array spot. So now, if you wanted to, for programming purposes, if it would be easier for you, you could actually leave the 0 index spot empty and then only deal so that the characters coincide with the actual array number, but then that would, you know, kind of throw some other stuff off. You would have to make sure that you're dealing with the right square every time you display a game board, and or display the game board and put in your inlines. What I've found in programming is that you just remember that arrays are zero-based indices, and then you just add one or subtract one where you need to. So here I'm going to take that in board spot. I'm just going to subtract 1 from it. Remember, if they type in 1 or 2, let's say they type in 2, that's actually array element 0, 1, array element 1. So we need to subtract 1 from what they give us. And then I'm going to stick in it the character X. Okay. Alright, so I need to declare this function. And so player turn, prompt user for location and place an X on the board in that location. Okay. Okay, and so what I want to actually do up here in my int main is I want to go ahead and display the board again to make sure that the element that the user chose gets picked and displayed. Okay, so now let's try this, run this. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Your turn. Pick a number to place your X. 5. All right. So it put an X right there in that location 5. And if you want to just make sure, you can run it again. Pick a different number, which I'm going to do here. I'll pick 7 this time. Make sure it puts an X in the 7 spot, and it does. Okay. All right. Alright, so at this point, I already mentioned before, thinking ahead, that if we continue to keep calling this player turn function, we need it to make sure that the user didn't pick, the user isn't picking a spot that has already been picked. We also need to do that for the CPU as well. So if we write it once now, then we will be able to replicate it when the user picks a spot. The only problem with trying to test this out now with the player turn is we don't really have a way to test it yet and until the game kind of progresses. So there's things we could do, and here's what I want to do. I'm going to go ahead and put this top part in a loop. Really, this is how it's going to go anyway. We're going to need this to be in a loop. It's going to display the board, have the player play their turn, and then display the board again. And then at some point in this loop, we'll have to have the CPU play. But I'm going to create a do while loop, and I'm just going to take this block right here, place it into my do while loop. Oops. This loop, we're going to want it to continue as long as someone hasn't won. And of course, that's a whole nother set of logic that we haven't written yet. But for now, what we can just do is we can kind of create maybe a little loop, an infinite loop if you want, or and of course go back and fix it later. So I'm just going to do while and just type in the word true there. So that will make sure my loop continues. Okay, so if I run this, okay, so I place a 5. Okay, now it hasn't picked anything for the CPU. Of course, we haven't coded that yet. But you know, now if I pick another number, it should place both of them. Okay, now if I pick the same number again, it just accepts it and puts that X in that 7, even though it's already been placed there. So that's what we want to, that's the next step. I want to code my player function so that it makes sure that I'm not picking a spot that has already been picked. Okay, so how do I do that? Well, let's go down here to this player turn function. Just like any validation, we're going to have a loop that asks the user to put the stuff in or pick a number and then receives it and then checks to make sure it's okay. If it's not, then loop back again. If it is, then exit the loop. Okay, so I'm going to encapsulate this into a do while loop. Do this. Prompt the user for a spot, place it, do that while the spot that the user chose doesn't already have an X or an O in it. So that will be game board, while game board, and then the spot that they pick is in board spot -1. Remember down here we subtract 1 since it's a 0-based index. So while the spot that they picked, if we want it to loop back, it's going to be a spot that is taken already. So while that game board spot is equal to either the character X, remember we're placing X's into that spot and O's into that spot, while the spot they pick is not X, or while the spot they pick has an X in it, loop back and ask them for to pick a different one. Okay, so the first time around everything should be fine. Your turn, pick a number to place your X. So I'm going to pick 5 again, and what it should do is loop back, which it did. So yeah, the 5 has already been chosen. Okay, so if I choose 7, then it works. If I choose 7 again, it should loop back. Okay. Alright, so that logic appears to be working. Now that is just checking for an X. We also eventually need to make sure that we check for an O as well. And also, we haven't validated whether the user picks a 1 through a 9. What if the user picked like 10 or -8? Obviously those wouldn't work. So we'll have to validate that as well. And I'll wait until we get the CPU stuff going, and then we can come back and make that change here. Sound good? Okay, so now that we've got the user playing, we want the CPU to play as well. So up here in my main, I need to prompt the CPU to take a turn. So I'm going to create a function to do that as well. CPU turn, passed it the game board. Okay. And it doesn't matter what order you do these in. I'm going to go ahead, since my functions are getting further down the way in my page here, I'm going to go ahead and create my declaration, function declaration at the top here, char game board, and I'll say that this function plays an O for the CPU in any random spot. So obviously, again, we're not going to have that intelligent code for the CPU trying to pick a spot that'll help him win, that will be to his advantage, or pick a spot that would block us. And that's there's a lot of different ways you can program that. If any of you have ever played a game like a game of chess, a computer game of chess, there's levels of intelligence that you can select. Just thinking about it, you could have the CPU be aggressive and its first move is to try to win, or you could have the CPU be defensive and its first move is to look to see if it needs to block the player. A lot of different ways you could approach that. So anyway, that'll be something that you can do on your own time if you'd like. We're just going to have it spit out a random O somewhere on the board. Okay, so then I need to define that function. I'm going to come down here below my player turn, void CPU turn, and it receives that character game board array. Okay, so the CPU is going to pick a number at random that is available. Now there's kind of a brute force way to approach this, and then there's also what would be maybe a little bit more efficient way. The fact that there's only 9 squares, I'm just going to take a brute force approach. What I mean by that is I'm just going to have a random number generated between 0 and 8, and then I'm going to attempt to play that spot, and I'll have a loop that will play in that square as long as it can. If the loop detects that there's already an X or an O in that spot, then it'll just loop back. So it is possible that it could pick a few random numbers that are wrong to begin with, and then eventually find one. But that is all going to happen in milliseconds time. There's only 9, and it should eventually get the right spot. Now, as the game board gets filled up, that might be something that would take a little bit more time. Again, it's not going to be something that you notice. Eventually, it's going to pick a number that is available because it's picking a random number based on the system clock. So it'll eventually get the right number, and you won't really notice an issue. But there's more than one way to program this, is what I'm saying. So I'm going to start with picking a random number. Okay, so if you remember from, I believe it was chapter 3 or 4, we first encountered this random number generator. So what you have to do is you have to seed the random number generator with the system clock. So seed rand or srand, and then pass to it time. And you always put 0 in the argument for that time function. And I'm going to have it put that random number into int choice. Okay, so I'm going to store in that choice. For integers, I usually do put an in front of there. Let's go ahead and do that. So in choice is going to get rand modulus 9. So remember, taking the modulus of that rand picks a rather large number, rather large integer. So if you just use the modulus of that and one more than the number that you're wanting to get, our array elements, remember, 0 through 8. So this will give us a number 0 through 8. Okay, and that needs to be in a loop as well. And we're going to have it continue while, and just like up here in our player turn, this is going to be the first criteria, while there's not an X there, but we also have to make sure there's not an O there as well. So I'm going to add that, and I just copied and pasted, change it to an O, while the game board choice is not an X, or there isn't an X there, or there is, or I'm sorry, this will loop back while there is an X or an O in that spot. Okay, and then we want to actually play on that game board spot, and so it's going to be just like this, only instead of subtracting 1, that's what the user types in. They're picking the number 1 through 9, which is 1 more than the actual spot. For the CPU, that's the actual, that's going to be the actual spot that we're wanting to pick. So this logic, actually not only this, but this logic all needs to be changed just a little bit. We're having a random number selected 0 to 8, which is the actual spot. So I'm going to delete that -1 there. That was, for the user, since the user is picking a number that's actually 1 more than the spot, that the array element location. So arrays can be a little bit confusing sometimes. This was the approach I took, is to have the numbered squares, and it's a little more straightforward, except for the fact that you've got a zero-based index. So you just have to keep that, take that into account. So it's while the spot they pick, 0 through 8, does not have an X or an O in it. And then when we actually play in that spot, that's the actual spot. And instead of an X, we want to play an O. Okay, so let's run it at this point. Oh, by the way, the random number generator needs a couple of things as far as the include statements go. We need the include ctime, I believe, and then we also need the include, I think, the C standard library, C stdlib. I think those 3 include statements will get our random number generator working. Okay, so if I run this, missing my semicolon. Oops. Oh, board spot. Yeah, since I copied and pasted that from the from the player stuff up here, that's not what we want there. It's in choice. I bet you all recognize that back when I did it. That's the disadvantage of copy and paste, is you can often forget. And what if it compiled? What if it was something that was fine? I've had that happen in my programming before, where I copied and pasted and forgot to change a little thing in a string, and it caused a big problem. Okay, same here, in choice. Alright, so the game board, as the user, I'll pick 5. Okay, and so it picked 1 for the CPU. My turn again. I'll pick 7. Okay, and so again, you didn't really notice an issue there. Although or a time lapse, although three of the spots were already taken, it would have had to sit here. This CPU turn function would have had to sit there and keep picking random numbers until it did not pick 1, 5, or 7. Yeah, let's continue on here. I'm going to pick 3 now. And we don't have the logic in there to win yet, so I've already won, but it hasn't told me that yet. And then the CPU chose a spot for it. It chose 2. Okay, so not an issue here. We can continue this out. If I choose 4, it placed my X in the 4, and again, not really much of a lapse there. The CPU chose 8, and the only one that's left is 9. Now, if we keep going, then we're going to be stuck in an infinite loop. So right now, it's stuck in a loop. The CPU's trying to pick a spot, but it can't because all the spots are taken. So, clearly we need logic in there that will declare a winner once we have a winner. So that's the next step. One thing before I do get too far there, with the user choice, I mentioned this earlier, but this user choice needs to be like this CPU choice. We can't pick right now. The user could replace one of the CPU's spots, so we don't want that, and we have to have the user pick a spot that's between 1 and 9. So I'm going to go ahead and add that logic in. So I'm going to take this, copy it, paste it here. So while the game board doesn't have an X in that spot, or while it does have an X, or it does have a O in that spot, it needs to loop back. Or if what they pick, or if what they pick is greater than 9 or less than 1. So I'm going to do or while in board spot is greater than 9, or in board spot is less than 1. Okay, so do you follow me on that? The user has to pick a number between 1 and 9. And we don't need that logic with the CPU because we're forcing it to pick something 0 to 8 because of this mod 9. Remember, the modulus returns the remainder after long division. So no matter what number I pick, no matter what number this random function picks, if I divide it by 9, the remainder is going to be somewhere between 0 and 8. So it has to be in that spot. Alright, let's go ahead and run that. And just to make sure, I didn't demonstrate earlier that the user could have picked a number 0 to 9. It would have, what it would have done is given you an error outside the bounds of the array. So now if I pick like 10, it'll loop back. Okay. All right, we're getting close. 48 some odd minutes in, 40 minutes in. We're getting close to having a complete game here. We just need the logic that determines whether there's a winner or not. Okay, and so we need to create a function. I'm going to create a Boolean function that returns true or false whether there's a winner. And then we need to call that function. So that's really the first question, is where do I call that? Well, remember down here in our do function, we've got do while true. It just continues on. So that's what I'm going to change down here. I'm going to say do while, and I'm going to call this function is winner. So that it's most of the time with a Boolean function you put is and it returns true if that's true. If there is a winner, return true. So is winner game board, I'll pass the game board to that function. While there isn't a winner, so it's actually I want this game to continue, so it's while that's false. If you wanted to, you could say while is not winner, and then you wouldn't have to have the equals false, but it's 6 in one, half a dozen in the other. So I'm going to create an is winner function. It returns true if there is a winner, and so my do while loop is going to continue while there is not a winner. Alright, so I'll go ahead and declare that function. Bool is winner. it also receives the game board. Okay, and so this function is going to return true if there is a winner, false if there is not. Okay, so we've declared the isWinner function. It's a Boolean function. We are calling it here. So now let's go ahead and define it, or write the function. Bool isWinner. It's receiving a character array that we're calling game board. Okay. All right, and there's a lot of different ways you could approach this as well. So the way I approached it is I first tested to see if there's a winner across rows. Then I tested to see if there's a winner down vertically in any of the 3 columns. And lastly, I tested to see if there's a winner diagonally. And if none of those, if it doesn't find a winner in any of those 3 methods, then we shouldn't have a winner. Okay, so what would that logic be? And I'll call this test for a winner horizontally down the rows. And we're testing for a winner, either computer or player. So all I really need to do is test to see, and let's go back to, I'm going to run this so that you can visualize the game board while I talk about it here. Okay, so I need to test to see if there is an X in all 3 of the, or an O in all 3 of these 1, 2, and 3. So in the array, that's element 0, element 1, and element 2. So I need to test to see if element 0 is equal to element 1 and element 0 is equal to element 2. Okay, if that's true, then I've got a winner. Or if element, and this is element 3 here, if element 3 is equal to element 4 and element 3 is also equal to element 6, or 5, I'm sorry. So then we would have a winner. Or we'd also have a row winner if element 6 is equal to element 7 and at the same time element 7 is equal to element 8. So if this is equal to this and this is also equal to this, then all 3 of them are equal by substitution. If you're wanting to know the actual mathematical proof there, if 7 is equal to 8 and 7 is also equal to 9, then 8 is also equal to 9 as well by default. And again, there I was using the actual number, not the element number. Okay, so we need to code that, and it's going to be a fairly complex statement here. If so the first one, and I'm putting this in parentheses as well because this is option 1. That's going to be row 1, and then I'm going to do or row 2 has a winner in it, or row 3 has a winner in it. So those parentheses in there, that's where I'm going to do the logic for that row, which both need to be true. And that logic's going to be game board. If game board element 0 is equal to game board element 1 and game board element 0 is also equal to game board element 2. Okay? Let that sink in for a second. Does that make sense? So I'm checking element 0. If it's equal to element 1, so if there's an X in both of them, or if there's an O in both of them, as long as they're equal, the characters are equal, we know that they have the same character in them. That has to be true, and at the same time, 0 has to also be equal to 2. Element 0 has to be equal to element 2. Then we've got a winner. Okay, I'm going to take that logic, copy it, and paste it into these other two parentheses areas that I created. Then I just need to make a slight change. So for this second one, so there's the first one, 0 is equal to 1 and 0 is equal to 2. For this next option, that's row 2, so that's going to be element 3 if element 3 is equal to element 4 and element 3 is also equal to element 5. Then we have a winner in the second row. And then this last one here, that's going to be the third row. So if element 6 is equal to element 7 and element 6 is also equal to element 8, then we have a winner in the rows. Okay. So if any of those things are true, or if any one of those three independently is true, then that whole thing will evaluate to true, right? If that's true, then we have a winner in the rows, so I'm just going to return true. Okay. Next, I'm going to test to see test for a winner vertically. Not really here. Instead of saying horizontally down the rows, I should say horizontally across the rows. Test for winner vertically down the columns. And this is going to be an else if. Okay, so else if I want to test for winners down the row, I'm going to do the same thing here. There's going to be, or columns, I'm sorry. There's going to be 3 columns, so if any one of those 3 columns has a winner in it, then we have a winner. So I'm combining with ORs the individual elements there. Actually, you know what probably the quickest thing to do? I'm going to just copy this entire logic from the top. All I need to do is change the numbers in it. But of course, you got to make sure you actually do change the numbers. Oh. And don't miss any. So I'm going to copy that. And yeah, I'm just going to paste it in right here. Okay, so what are the columns going to look like? If you got a winner down the column, it's going to be element 0. If you want to picture that 1, 2, 3, 4, 5, 6 again, I'll throw it up on the screen right now. So down the column would be 0, element 0 and 3 are equal, as well as element 0 and element 6. So if element 0 is equal to element 3 and element 0 is also equal to element 6, we have a winner. Or if element 1 is equal to element 4 and element 1 is also equal to element 7, then we have a winner. Or if element 2 is equal to element 5, we have a winner. Well, if element 2 is equal to element 5 and element 2 is also equal to element 8, then we have a winner. Okay, so those are the options for there being a winner down the columns. If any one of those 3 independently are true, and in order for them to be true, that we need to have the first element equal to that second element, as well as that first element equal to that third element in that column. Then we have a winner. Return true. Okay. And then well, not quite lastly, but next, we need to test for diagonals. So I'll say diagonal winner. That's going to be another else if. Okay, this one's going to be a little bit simpler. I'm just going to take two of these because we only have two diagonals, right? Copy two of those. Paste them in here. Okay, the diagonals are going to be element 0 is equal to element 4. 4 is the middle element, right? And element 0 is also equal to element 8. That's a win. If 0 is equal to 4 and 0 is also equal to 8, we have a diagonal win. Or if this is true, if element 2 is equal to element 4, which again is the middle element, and element 2 is also equal to element 6, then we have a diagonal winner. Okay, so if any of those are true, so element 0 equal to element 4 and element 0 equal to element 8, that's a diagonal win. Or if element 2 is equal to element 4 and element 2 is also equal to element 6, then we have a winner. So I'm going to do return true there. Okay. Okay, and then the last thing here, we need to check for a cat game. And the cat game, if you haven't heard that term, it's just the board is completely filled and no one has won. So how do I check to see if the board is completely filled? Well, I can just go through the for loop and look at every element, and if I find an integer, or actually I'm sorry, if I find a numbered character in any of those squares, then I know that there's an empty spot. Maybe the easier thing to do instead of checking for a number is I can exit. I'll exit the loop if there's something other than a 0 or an X or an O. Sorry, not a 0 but an O. Character O. So I'm going to do for int, and I'll just use n equal to 0. In less than, remember we've got that squares up there we can use to cycle through our entire array. In plus plus. Okay. Okay, so going through the entire board, if at any point the game board element, in, if it is not equal to X and at the same time it is not equal to O, then we know that there's one of those other characters in there, so we have an empty spot, not equal to O. Make sure you use the O character, not the 0, and they're close to each other on the QWERTY keyboard. Okay, does that logic make sense to you? The alternative, I guess you would have to say, well, if it's not equal, or if it is equal to the character 1, or if it is equal to the character 2, or if it is equal to the character 3, you'd have to go through there. Or possibly you could take the character and try to convert it to an integer, and if it converts to an integer, then you know then it's an open spot. This was my approach. I said if there's not an X and there's also not an O in that spot, then I'm going to return false. It's not a cat game. Otherwise, if it's gone through the entire array and it did not find, at no point was there not an X and also not an O, then we have a cat game. So I'm going to do a cout statement here and say cat game. And then I'll return true. Returning true means, well, even though the cat's the winner, the game should be over, which is going to quit our loop there. So that's what we need. So it'll return true. So now we have the logic that should check to see if we have a winner, is winner. Okay, and we're calling it here, is winner, game board. While that's equal to false, continue. Now we're not quite done yet. Let's go ahead and run this and check and see how it turns out. And I think there's one minor change that we want to make so that our game plays a little more smoothly. Alright, so I'm going to pick 5. Okay, this CPU chose 1. I'm going to pick 7. CPU chose 6. So I should be able to win right here with a 3. Now the only thing here is, look at our logic. After the player takes a turn, it will display the board, and the CPU is going to go ahead and take a turn as well. So what you're going to see here is it says your turn, pick a number 3, and it put it in there, and then the CPU picked a square, but we didn't, of course we didn't really care what they picked, but then it just exited the game, and then that was it, and then you don't see anything. Okay, so what I want it to do instead is, I'd like for it to show me, hey, that there was a winner. Now the question is, who actually won? Now if you wanted to, I'm going to put an inline in here. Winner, winner, chicken dinner. If you wanted to, you could determine who won by what the last, or who played last, and that would be based on based on who took the last turn, or what we could do. Another way to go about checking to see who it was that actually won, here in our is winner function, we could instead of having it return a Boolean, or, well, I guess there's a couple of things you could do. You could have it return the character that's who is the winner, or I guess within the is winner, we could actually have it display who the winner was. So here, I could say, so if game board 0, or, well, of course then you don't know exactly which one of these. You'd have to check to see who the winner was. So anyway, there's ways you can go about finding out who won. But for simplicity's sake, again, we're already an hour in. So if you would like to do that on your own time, that's awesome. I'm just going to say winner, winner, chicken dinner, and the game's over once somebody wins. Now the only other issue here, actually, let me test out the cat game first. I want to try to play to a cat game. So I'll play 5. So I'm going to play 7 there, since that's not going to benefit me in any way. So then there, I'm going to play 6. Actually, let me try to see if I can get the computer to win. I'm going to play 8. I'm just going to continue to not pick 6. So a computer can win 2 spots. So actually, if I pick 4 here, then I should induce a computer win. Yeah, so the computer won. Now it didn't show us. It didn't show us where the computer picked. So that's one thing I'd like to change. It looks like our our logic for the computer, the O's, is working fine. However. Okay, so after the CPU turn, we don't actually see the game board being displayed again. So if you'd like to, we can put in a display board. So if I do that, and now run it, let's try to play to another loss, so we actually see the computer's choice on a loss. So I'm going to go 5. Computer chose 1, so I'm going to pick 9. Let's see, computer chose something that's not really helpful to him. I'm going to go with a 2 then. I'm just going to continue to play. Actually, I'm going to pick 6 instead. Okay, so then now, yeah, of course the computer played there. This looks like it's going to be a cat game. No, that's fine. Let's play to a cat game. We need that anyway and make sure that logic works. Ah, computer chose 2, so he won. Good for him. Alright, so there, now we actually see the computers win. Winner, winner, chicken dinner. Okay, let me try to play to a cat game. There, I didn't quite make it. I was trying to play to a computer win there. Okay, so chose 5. I'm going to choose 4 this time. Okay. I'm going to go with 9 since that... okay, computer blocked me, which is good. I'm going to pick 2. And no matter where the computer plays here, we should get a cat game. Yeah, so my only choice is 7. So there. Now actually, we're going to get stuck in a loop here because, and this is the other thing I wanted to address, if I pick the last spot and note that's a cat game, then the game will freeze. The computer's trying to pick somewhere and it can't. Well, there's a couple of different ways you can fix that. One, I suppose what we could do is in the CPU turn, we could have it also test to see if there's a cat game. So this is something maybe we could pull out and make it its own function. But what I did instead, instead of doing all that extra work, what I'm going to do right here, after the display board here in my loop, I'm going to circumvent, or I'm going to exit the loop. I'm going to do is winner. So I'm testing for a winner twice here, after the player plays and then after the CPU plays, which really makes more sense to me. After everyone plays, the game board should, or after each individual turn, the game board should be evaluated to see if anyone won at that point, or to see if the game board has been filled up at that point. So I'm going to do if is winner game board here, and I'm just going to do break. Remember, break breaks out of a loop at any point. So that break will break out of this do while loop, and we'll see winner, winner, chicken dinner. Now the only problem with this winner, winner, chicken dinner here at the end is what happens if there's a cat game. Oh, currently we're displaying, it'll say cat game here, and it'll return true, and then we'll see cat game, then winner, winner, chicken dinner. So if you wanted to, you could maybe put this somewhere else. If you want to put that winner, winner, chicken dinner statement maybe exclusively in here, that would be fine in each of these 3. Okay, so I want to test those 2 things, and then we should be at a point where we're done with this project. So I'm going to play at 5 again. CPU played, I'll play at 8. CPU played at 6. I'm going to play at 3. Okay, CPU chose 9. And I will choose 1. CPU chose 4. So 7's the only available spot. If I choose 7 here, I should get a cat game. Now it displayed the winner, winner, chicken. Oh, yeah. Pfft, I did win. Okay, well I did win that game. Let's try to play to a cat game. I think maybe if I don't choose 5, it might be easier to play to a cat game. Alright, there the user chose 0. I'll choose 9. Or, I'm sorry, they chose 6. Okay, they chose 5, so now they got that mental advantage. I'm going to play at 3. Okay. Now here, if I played at 1, the CPU could choose. Well, if I played at 1, then either I'm going to win or the CPU is going to win. So I don't want to do that. If I play at 2, I block them, but then he could possibly play at 7, which would be a win for me. If I play at 7, then he could play at 2 and he could win, or he could play at 1. So either way, I think there's a 50-50 chance that it'll either be a cat game or a win for one of the two of us. I'll go with 2, and CPU forced me to win there. Okay. So anyway, I'm going to keep playing here until I actually get a cat game, just to make sure that my cat game logic is working. I'll go with 8. And 4, how about? Okay, that's good. Alright, so now if I play at 3, again, 50-50 shot here. As long as he doesn't play at 1, then I should get a cat game. And he didn't, so that's good. So if I play at 1, then we get the cat game. And like I said, it does say that winner, winner, chicken dinner. If you want to move that out somewhere else, you can. But it looks like we've got a working game. The user can play, and the CPU just plays at random anywhere. So what I would like for you to do is put your own personal touch on this before you turn it in. As long as you get this and turn this in working, you'll get credit for these points. But I do want you to spend some more time on this. I would like for you to either customize your game board, make it look a little bit better, a little more flashy, or at the very least, maybe make a change with this winner winner and have it so that if there's a cat game, that it doesn't go on and say that winner winner. Other things you can do to improve this game is try some logic for the CPU. So in here you could have it evaluate where it should play, as opposed to just picking a number at random. So now that's going to be a little bit more involved. If you feel confident that you want to spend some time on that, then I definitely encourage you to do it. But happy programming. So again, happy programming, and know yourself.